To begin, we need to install the Arduino IDE on our computer. Open your web browser and go to the official Arduino website. Once the website loads, click on the Products menu and then select Arduino IDE. On the Arduino IDE page, scroll down to the Download section. Here, choose your operating system from the drop-down menu. After selecting your operating system, click on the Download button to begin downloading the installer. Once the Arduino IDE file is downloaded, open your Downloads folder and double-click on the Setup file. This will open the installation window. Now simply follow the on-screen instructions and click Next wherever required to complete the installation. During the installation process, you may see a user account control pop-up asking for permission to make changes to your device. Don't worry, this is completely normal. Just click Yes and allow all permissions. If you skip this step, you might face issues later when connecting your Arduino board to the computer. And that's it. The Arduino IDE is now installed on your PC. Before we begin, let's quickly go through the components required for this tutorial at this moment. First, you will need an Arduino UNO board. In this video, I am using the official Arduino UNO R3. However, any compatible Arduino UNO board will work perfectly fine. If you are just getting started, you can also use a clone version of the Arduino UNO. These are widely available and much more affordable, making them a great option for beginners. Alternatively, you may use the newer Arduino UNO R4 if that is what you have. Next, you will need a USB-A to USB-B cable to connect the Arduino board to your computer for both power and programming. The Arduino UNO is a widely used open-source microcontroller board based on the Atmega 328P microcontroller, with a dimension of approximately 53.4 mm by 68.6 mm. Making it compact and suitable for a wide range of projects. The board features 14 digital input and output pins, which can be used to read digital signals or control devices such as LEDs, relays, and motors. In addition, it provides 6 analog input pins, allowing you to read analog signals from sensors such as temperature sensors, potentiometers, or light sensors. The Arduino UNO operates at a clock speed of 16 MHz. In terms of memory, it includes 32 kilobytes of flash memory for storing your program code, 2 kilobytes of SRAM for temporary data storage while the program is running, and 1 kilobyte of EEPROM for storing data that needs to be retained even after power is removed. The Arduino UNO also supports 3 primary communication protocols: UART, I2C, and SPI. These communication protocols allow the board to interact with a computer, connect to various sensors, or communicate with other microcontrollers and modules. Arduino UNO operates at 5 volt with a recommended input voltage of 7 to 12 volts. Now that we have an overview of the board specifications, let's move on and examine each component on the Arduino UNO in detail, including its purpose and function. At the center of the board is the main microcontroller chip, the Atmega 328P. This is the brain of the Arduino UNO. It executes the compiled program code that you upload through the Arduino IDE and controls every operation performed by the board. On the screen, you can see some additional technical features. If you would like to review them in detail, feel free to pause the video and take a closer look. In addition to the main microcontroller, the Arduino UNO also includes a second microcontroller, the Atmega 16U2. This chip is primarily responsible for handling USB communication between the Arduino UNO and your computer. It converts the USB signals from your computer into serial communication signals that the main microcontroller can understand. Additional technical specifications of the Atmega 16U2 are displayed on the screen. You may pause the video here if you would like to examine them. Another key component on the Arduino UNO board is the LM358 operational amplifier. The LM358 includes 2 internal amplifiers within a single package. One amplifier is responsible for automatic power selection between the USB supply and an external DC adapter. When both power sources are connected, it functions as a comparator, monitors the voltage levels, and selects the appropriate source to prevent power conflicts. The second amplifier is configured as a buffer for the onboard LED, connected to digital pin 13. This buffering ensures reliable LED operation, while protecting and isolating the microcontroller pin. The Arduino UNO uses a 16 MHz crystal oscillator to provide a precise and stable clock signal. This means the microcontroller operates at 16 million cycles per second. This clock signal synchronizes all operations of the ATmega 328P microcontroller. In simple terms, the crystal acts as the timing reference that keeps the entire system running in sync. Now that we have covered the main functional sections of the Arduino UNO, let's move on to the input and output pins. These pins act as the primary interface between the microcontroller and the external world. They allow the board to read signals from sensors and control various external devices. On one side of the board, you will find 14 digital input and output pins, labeled from 0 to 13. These pins can be used to read digital signals, such as high or low, or to control devices like LEDs, buzzers, and relays. Some of these digital pins also support PWM, which allows you to simulate analog output. These PWM-enabled pins are marked with a tilde symbol next to the pin number. On the opposite side of the board, there are 6 analog input pins labeled A0 to A5. These pins are used to read analog signals from sensors. For example, you can connect a temperature sensor or a potentiometer and measure varying voltage levels. Near the analog input section, you will also find the power pins. These include 5 volts, 3.3 volts, ground, and V-in. These pins allow you to power external components directly from the Arduino board, or supply power to the board itself through the V-in pin. Now let's understand the different indicator LEDs available on the Arduino UNO board. These LEDs provide useful visual feedback about the board's status and operation. The first LED is the power LED, usually labeled as on. This LED turns on as soon as the board receives power, either from the USB cable or an external power supply. Next is the built-in L LED. This LED is internally connected to digital pin 13. It can be controlled directly through your program using pin 13. This LED is commonly used for testing. You will also find 2 small LEDs labeled TX and RX. TX stands for transmit, and RX stands for receive. These LEDs blink whenever the board is communicating with the computer through serial communication. For example, they flash during code upload or when data is sent or received using the serial monitor. These indicators help you confirm that serial communication is working properly. Now that we understand the onboard LEDs, let's take a look at a few more important components on the Arduino UNO board. First, we have the USB port. This port is used to connect the Arduino UNO to your computer using a USB cable. It serves 2 main purposes. First, it allows you to upload code from the Arduino IDE to the board. Second, it provides power to the board during development. Next to the USB port, you will find the DC power jack. This allows you to power the Arduino using an external power adapter, typically between 7 and 12 volts. This is especially useful when your project needs to operate independently without being connected to a computer. Near the DC power input section, there is a protection diode that functions as a rectifier. Its primary role is to protect the board from reverse polarity and also suitable for converting AC power to DC. This helps safeguard the board from potential damage. The 2 voltage regulator ensures that the board receives a stable 5 volts and 3.3 volts for reliable operation. Near the USB port, you will find the reset button. Pressing this button restarts the microcontroller and begins executing the uploaded program again from the beginning. This is helpful during testing and debugging. Finally, there is the ICSP header. ICSP stands for In-Circuit Serial Programming. This header is mainly used for directly programming the microcontroller or burning a bootloader, typically in advanced use cases. Before writing more complex sketches, it is important to understand the basic structure of an Arduino sketch. Every Arduino sketch follows a simple and consistent structure. Typically, an Arduino sketch contains comments, library inclusion, global declarations, the setup function, the loop function, and optionally user-defined functions. Let's go through each of these sections one by one. At the beginning of many Arduino sketches, you will often see comments like this. Comments are lines in the code that are written for humans to read and understand. They are ignored by the compiler and do not affect how the program runs. Arduino supports 2 types of comments. The first type is a single-line comment, which is written using 2 forward slashes, like this. Anything written after these slashes on that line will be treated as a comment. The second type is a multi-line comment, which is useful when writing longer explanations or documentation. A multi-line comment starts with a slash and a star, and ends with a star and a slash. Using comments properly makes the code easier to understand, maintain, and debug. Below the comment section, you may see library inclusion statements like this. Libraries provide additional functionality that allows the Arduino to interface easily with sensors, displays, communication modules, and other hardware devices. Libraries are included using the #include statement like this. Including the correct library ensures that all the required functions and definitions are available for your program. Below the library section, you will find the global declarations. This is where variables, constants, and pin definitions are declared. These are called global variables because they can be accessed from anywhere in the program. Declaring them globally helps keep the code organized and easier to manage. Next is the setup function. The setup function runs only once when the Arduino board is powered on or when it is reset. This section is used to initialize hardware and configure settings. For example, you may configure pin modes, start serial communication, or initialize sensors and communication modules. Since this function runs only once, it prepares the system before the main program starts running. After the setup function completes, the program moves to the loop function. The loop function runs continuously in a cycle for as long as the board is powered. Any instructions written inside this function are executed repeatedly. This is where the main program logic is placed. For example, the Arduino may read sensor values, process data, control outputs, or communicate with other devices inside the loop function. In addition to setup and loop, you can also create your own functions, often called user-defined functions. These functions are used to organize code into smaller, reusable blocks. Instead of writing the same code multiple times, you can place it inside a function and simply call that function whenever needed. For example, you might create a function to read a sensor, control a motor, or blink an LED. Using functions makes your program easier to read, maintain, and debug. Now, let's upload our first sketch to the Arduino UNO. First, connect the USB cable to the Arduino UNO board. Then connect the other end of the cable to your computer. Once the board is connected, open the Arduino IDE software. Now, go to Tools, then navigate to Board. Since the Arduino UNO belongs to the AVR family, select Arduino AVR boards, and then choose Arduino UNO from the list. Next, go back to Tools, then click on Port, and select the appropriate port. The port number may be different on your system. Simply select the port that appears when the board is connected. You can also select both the board and the port directly from the drop-down menu available in the IDE interface. If the board is properly connected, you should see Arduino UNO displayed next to the selected port number. For example, in my case, it shows COM5. Now, go to File, then click on Examples. Navigate to Basics and select the Blink sketch. This is a simple example program that turns the built-in LED on and off continuously at a 1-second interval. Next, click on the Verify button to compile the sketch and check for errors. If there are no errors, click on the Upload button to upload the sketch to the Arduino UNO. During the upload process, you will notice the TX and RX LEDs blinking rapidly. This indicates that the code is being transferred to the board. Once the upload is complete, the built-in LED will start blinking. This confirms that the sketch has been successfully uploaded and your Arduino UNO is working correctly. To demonstrate how to use the serial monitor and serial plotter, first let's open the Read Analog Voltage sketch from the examples. To do this, go to File, then Examples, then Basics, and select Read Analog Voltage. This is a simple sketch where we read an analog voltage using analog pin A0. The analog value is first read using this statement. Next, using this formula, the analog reading is converted into a readable voltage value. Finally, the calculated voltage is printed to the serial monitor using this statement. Whenever you want to use the serial monitor or serial plotter, make sure to initialize the baud rate inside the setup function using this statement. Now connect the circuit according to the circuit diagram shown on the screen. Once the circuit is ready, verify and upload the sketch to the Arduino board. After the sketch is uploaded, open the serial monitor. To do this, go to Tools and click on Serial Monitor. Or you can use the shortcut button available in the Arduino IDE. Once the serial monitor opens, you will see the voltage value being displayed. Now, if we adjust the potentiometer, the voltage reading will change accordingly. Next, let's view the same data using the serial plotter. Go to Tools and select Serial Plotter, or use the shortcut button available in the IDE. The serial plotter displays the data in a graphical format. Now, when we adjust the potentiometer, you can see the voltage changing in real time on the graph. If you want to remove any previously uploaded sketch, you can simply upload an empty sketch like this. Uploading a blank sketch like this will overwrite the existing program stored in the Arduino. However, keep in mind that this method only clears the main program stored in the flash memory. It does not affect any data stored in the EEPROM. If you also want to clear the EEPROM memory, we use this simple sketch, where we include the EEPROM library, which allows us to access the internal EEPROM memory of the Arduino. Inside the setup function, we use a for loop to iterate through all memory locations. The function EEPROM length gives the total size of the EEPROM. For each address, we write a value of 0 using the EEPROM write function. This effectively clears all stored data. Once the process is complete, we also turn on the built-in LED on pin 13 to indicate that the EEPROM has been successfully cleared using this statement. Since this operation only needs to run once, the loop function is left empty. Before continuing, let's understand how to install libraries in the Arduino IDE. To install a library, go to Tools, and then select Manage Libraries. Alternatively, you can click on the Library Manager icon to open it directly. Once the Library Manager opens, you can search for any library using these 3 search options. After finding the required library, select it from the list. Next, choose the appropriate version from the drop-down menu. Then, click on Install. In some cases, you may see a pop-up asking to install additional dependent libraries. It is recommended to click on Install All, so that the library works correctly without any issues. For now, I will install it without the dependencies. Once the installation is complete, you will see a success message in the output window. You will also notice an installed label next to that library. At any time, if you want to remove a library, simply click on the Remove button. That's it for this video. I hope you found this tutorial helpful. If you did, don't forget to like, share, subscribe, and turn on notifications so you don't miss future uploads. Thanks for watching, and I'll see you in the next one.